Hello everyone and welcome back to my channel. In today's video I will be reviewing a problem from the Iran Mathematical Olympiad round 3. It's a geometry problem and the problem is the following. We have an acute triangle ABC where D is the foot of altitude from A to BC. We have points K and L. K is on the circle ABD such that, hold on, let's get the circles, and the second circle. So KD is tangent to ADC, and LD is tangent to ABD. And we have a point S we have a point S such that ACB plus ACS is 180 degrees and ABC plus ABS is 180 degrees too. Okay, now I'll make my first claim is let A prime be the antipode of A in ABC, and I'll prove that A prime, and S are collinear. Now, the first thing that we want to notice is that the angle ACS equals 180 minus the angle C from the problem statement. This means that angle BCS equals 180 minus 2 times angle C. So the angle A prime C, this means that A prime CB equals A prime CS. This is because A prime CB is 90 minus the angle C, and A prime CS is 90 minus the angle C as well. Now this means that A prime is the incenter of the triangle BSC. It is because two bisectors give an incenter. This means that A prime S is the internal bisector of BSC. This means that angle A prime SC equals 190 minus the angle A, which is just a simple angle chasing. Because we know these two angles, we can find out the third. So this means that angle SA prime C equals 180 minus the angle B. But we knew that A prime C equals the angle B. So it means that these 3 points are collinear. Now that we have derived that, I'm going to introduce some new points. By the way, now that we have derived that A prime, and S are collinear, this means that A is the excenter in the triangle BSC. This is because AC A prime and AB A prime are both perpendicular, both 90 degrees. Now let T be this point and R be this point, where CB cuts this circle and CS cuts, SB cuts the circle ABD, and SC cuts the circle ADC. Now I'll prove that KTB and RLC are similar triangles, which we will use later. Okay, why is this the case? Well, we know that, hold on, let me connect these. Well, we know that ARS is 90 degrees. So, by the way, these points, T and R, will be the in-touch points, will be the touching points of the X circle with SB and SC. So A is the center of the circle TDR. Okay. Now what does this mean? This means that T is the reflection of D across AB, and R is the reflection of D across AC. This is because AB is the diameter of the circle, and A also lies on the perpendicular bisector of the thing TD. So this is 90 minus the angle B, and this is 90 minus the angle B as well. Now on the other side, we know that DAL. Okay, what does LDA equal? LDA equals the angle DBA because of the tangency, and DBA equals the angle B. This is the angle B, and this is the angle C. So the angle DAL is the angle A. So since this is 90 minus angle C, then this will be 90 minus angle B. So TAB equals angle CAL, and since TAB equals CAL, this means TAB also equals TKB, and this equals CRL. Okay. So we have derived that CRL and TKB are equal angles. Now, what about KT? Well, KAT, let's count that angle. KAT, the angle KAT equals the angle KAD. So the better way to count that is the angle KDB, minus 90 plus the angle B. Well, why is this the case? Because KAT equals KAB minus 90 plus angle B, but KAB equals KDB, and the angle KDB equals what? KDB equals 90 minus angle C. So this means that the angle KAT equals the angle B minus the angle C, and by counting the same way, we'll get that and this equals KBT, and by counting the same way, we'll get that RCL is the same angle, yeah. Now, since two angles are the same, the third one has to be the same too. So we have derived that STK and, hold on, I accidentally deleted this. This was L. STK and the angle, so STK and RLC are equal. Okay. Now we do a method called root BC inversion, which is just an inversion with in the triangle BSC. We perform an inversion with the radius SB times SC, square root of that, and then we follow by reflection around SA prime, which is the internal bisector of BSC. Okay. So what does this mean? Let us introduce the point J on the circle of BCS. I'll actually call it D prime. So there's some random point here. Call it D prime. It's where D goes after the inversion. And it's also known as the S mixtilinear in-touch point in SBC. And we also know about two more points. We'll denote them by R prime and T prime. they are points that where T and R go respectively, and some well-known facts state that R prime, A prime, and T prime are on the same line, and we also know that B, D prime, A prime, R prime are on the same circle, and C, T prime, A prime, D prime are also on the same circle. These are just quick facts about mixed linear circles, which are really easy to prove. Okay, now what we want to prove is that let K prime and L prime be points on these circles, because look, after we perform the inversion, the circle ADC will come to this circle B D prime A prime, and the same way ABD will come to this circle. So L prime will lie on this circle, call it omega 1, and K prime will lie on the other circle. Our goal is to prove that K prime, L prime, and A prime are on the same line, because if they are on the same line, before we perform the inversion, they would be on the same circle with S, and that's what we want to prove. Okay, now I will prove that B L prime S and C K prime S are similar triangles. S K prime C, what does this equal? Well, by the inversion facts, we know that this equals S B K. Why is that? Because C is actually B prime, because B and C swap positions. So SBK and SL prime B equals the angle SCL. And S, it's easy to denote. Well, let's just prove that these two are indeed equal. Well, the angle KBA is equal to the angle C, right? And the angle SBA is equal to 180 minus SBA is equal to 180 minus B. So the angle is 180 minus B plus C, and SC prime L, well, SC prime D is 180, SC prime A is 180 minus the angle C, and LC prime A is the angle B. And since SC prime L is greater than 180 degrees, well, it just matters, because B is greater than C in this case, this will be greater than 180 degrees. So if we take a half plane of SC prime, L will be on the other side of this rather than D. So in reality, SC prime L equals 180 minus the angle B plus the angle C, because it needs to be less than 180 degrees. So these two are equal. Now for the triangle similarity, we need to prove that L prime B over L prime S equals K prime C K prime C over K prime S. Now we can rewrite this as K prime B, L prime C prime over L prime S needs to equal to K prime B prime over K prime S. Now we can use the inversion formula. L prime and we can rearrange these. So we need to prove that SK prime over SL prime equals K prime K prime B prime over L prime C prime. by just overwriting. SK prime is the same as SB. Hold on. SK prime is the same as SB times SC over SK. And then we divide this by SB times SC over SL, which we get SL over SC. So we need to prove that these two are equal. Now, by the inversion distance formula, we get K prime B prime is equal to SB times SC times KB over SK times SB. And L prime C prime is equal to SB times SC times KB times LC divided by SL times SC. So dividing these two by each other, these will cancel out, and we get SL times SC divided by SK times SB times KB over LC needs to be equal to SL over SK. Now these will cancel out, and we need to prove that SC over SB is equal to KB over LC. And how do we prove that? Well, we need to prove that this equals to LC over KB, because their product needs to be 1. So let's delete everything. And focus on what we need to show. We need to show that KB over SB equals SC over LC. Now, how do we do that? Well, let's M and N, introduce M and N, which are midpoints of AB and AC. And they're also centers of these circles, because AB is the diameter. M and N. That KB over MB equals 2 times cosine C, because of the sine theorem K and B. This angle is 180 minus 2 angle C, and this is angle C. So KB equals AB times cosine C. Now AB over SB, what does that equal? This equals cosine of the angle A divided by sine of 90 minus angle C, which is cosine of the angle A divided by sine of the cosine of C. So KB equals cosine of A times AB. But since cosine of A is independent from B and C, by applying the same thing to LC over SC, so this needed to be 1, my bad. So by applying the same thing, we get that LC over SC is also cosine of A. Now that we proved that these two triangles are similar, what does that actually get us? Well, we get that the angle L prime BS, this we know that equals L prime B R prime, and we also know that this equals the angle K prime CS, which equals the angle K prime CT prime. But from the cyclicity of these, we get that this angle, we know that this angle equals L A prime R prime, and this equals K L prime A prime R prime, and this equals K prime A prime T prime. But since R prime, A prime, and T prime are on the same line, and these angle conditions implies that L prime, A prime, and T prime will also be on the same line, which finishes our problem. That's it for today. See you in the next one.